machine learning trainer in Indian cybersecurity solutions, and today I'll be talking about the Numpy module. And using the module, today the topic of discussion will be more on how, by using this Numpy module, we'll be creating an array, or one-dimensional or multi-dimensional array. So the first topic of discussion that we're going to go through is what is Numpy, what is the basic module, what it does, what are its functionality, and then next form is we are going to stress today in this topic, we are going to stress more on how we are going to create an array. So let's go to the next part of how or we utilize NumPy and when do we utilize NumPy, why do we do it. So basically, NumPy is a general purpose array processing package in Python. So using NumPy module, there are many ways in which you can take in numeric values and do multiple arithmetical functions through it by converting those multiple numbers into a particular array. Now, the second is provides a high-performance multidimensional array object and tools for working with these arrays. So basically, it not only helps in creating a multidimensional array, and it also helps in doing any mathematical operations or any other kinds of operation on these arrays. So it has many functionalities within itself. Third point is, can also be used as an efficient multi-dimensional containers of generic data. So basically, like say suppose for this image, the image is pixelated. So each and every points of the pixels have an RGB value that need to be stored in a particular array format so that we do not jumble up the coordinates of each and every pixel's positions. So using NumPy array, we can store these generic data. Next part is, as we are talking more of what array is, so what is basically array? Now array is a table of elements of the same type. It's basically in using Jupyter or in Python, your array is showcased somewhere like this. So it's a table of elements of the same type. So basically it contains the same data types within a particular table, or you can say it's more of like an array. Now, dimension of the array is what we call as a rank of the array. So as you can see here, rank 1, because the array is of one dimension. So basically this array is rank 1. As you can see, this array is also your, how will I say, it's two-dimensional. So basically this array is rank 2. But this one, sorry for the denotations, but I couldn't show the huge amount of data that could be showcased out here. But if you had a three-dimensional array out here, so basically that array would be named as your rank 3. Now moving on to the next part. So there are many in detail functionalities of these arrays. First of all is a tuple of integers gives the size of the array along with each dimension is known as the shape of the array. So there is a functionality in NumPy where you can just by writing dot shape or using the dot shape functionality, which I'll show you later on, you will see the output would be somewhat like this. If your matrix is somewhat in this manner, which is a two-dimensional matrix of two rows and three columns, then if you write, say suppose if you use that dot shape function, then it will show you in this manner. A tuple of two numbers, one being your denoting your number of rows and the other denoting your number of columns. Now moving on to the next point, saying that elements of the array are accessed using square brackets. So basically, if you are, if say suppose I'm considering this one-dimensional array of all these numbers, like 11 elements in a particular one-dimensional array. Say suppose I want to fetch this element of that array, one-dimensional array. So what I do is that as these elements that are present in this one-dimensional array, each of these elements have a particular indexing value or a particular position value. Like, and it's by default, it's every time it is considered that the beginning position to be 0 and the ending position to be wherever it has to be. Say suppose here we have 11 elements, it starts from 0 ends till 10. So be it as we want to just fetch this element only, solely this element. So basically we have to write array, that is, this is the variable name that I have used, that I'll be showing you, the variable name that you can use to store a particular array. So this is the variable name ARR that I've used to store this one-dimensional array, and in that I have within the square brackets I have written the position value, that is 8. So corresponding to the 28 value that I want to fetch, it has a value 8, that is the position value, which I have denoted out here. And if I just print this, or if I want to write, if I write this basically, then I'll be getting this as my output. That is, accessing the elements isn't within a particular array. Now the next part is how we are going to create an array. There are several processes in which we are going to create an array, and as you can see, you can not only create a one-dimensional array, you can also create a two-dimensional or a multi-dimensional array, which I'm going to show you one by one. So there are many processes. First being using various data types or lists, tuples, and etc. If you have a basic idea on Python, then you would have an idea on what list, what tuple is, and what set and what dictionary is. So basically, those are literals, collection of literals that we are going to use, and we are going to convert these literals into a particular array. So we are going to show how we are going to use this for creating not only one-dimensional but also in multi-dimensional array. Next part is series of numbers as inputs using various syntaxes. So as we can see that we are using a third party like a list or a tuple or a set or a dictionary to be as your input for converting them into a particular array. But you can also regenerate or you can recreate an array by just creating a series of numbers or a particular way in which or a sequence of numbers. So not only does it help us in creating a one-dimensional array, but we can also make use of it and produce a two-dimensional or a multi-dimensional array. Next part is random numbers as inputs using random function. So using the random function, we can generate random numbers and we can also create an array of not only one dimension but also in two dimensions. Secondly, by defining the size of the array, so we can not only mention the we can just mention the size of the array like I've already shown you out here. We can just mention the shape of the array, the number of rows, the number of columns, and the number of dimensions, and create just not only one dimensional but also two dimensional and multi-dimensional arrays. Next is creating identity matrix and fixation of the random functions, and then I will also show you there are a few more types of ways of creating a one-dimensional or two-dimensional array. Either you can use them to create a null matrix or limit matrix, anything. So let's move on to Jupyter and see what are the functionalities that we're going to use. Now, first off, we have to import the package, right? So basically we write something like this, import numpy as np, right? So if you write this statement, basically you're importing the numpy module out here. Now once you have imported the module, let's move on to the next part where we are going to show you first how to create a one-dimensional array. Now the sub part of that is we are going to first show you how to use various data types like your literals, like list, tuple, sets, and dictionary, and convert them into a particular array. Now as you can see, this is a particular list out here with your 4 digits, that is 4 numbers, that is 3, 6, 9, and 12. So how, and I will store that in a particular variable which is d, and we're going to convert this particular list into an array type. Let's see how we're going to do that. First we have to write np.array, and within brackets we are going to just notify d out here. So if you do that and run it, you will see you will get an array. So this list basically has converted into a particular array. Now moving on to the next part, we are going to show you how to use a tuple and convert that into array. In a similar manner, if you just write np.array and then just mention the variable where you have stored the tuple, that is d, as I've done here, and run it, it will convert that into an array. Now for a string, basically what happens, if you convert a string into a particular array, it can be easily converted into an array. But it somewhat looks like this of the string where I've stored a string in variable s, so s, and I've run it. So basically the whole thing, this whole string has converted into an array type, but this is not much organized, as if you want to convert a string into an array, you want to fetch each and every element. So I put an extra step out here. Let's see, this. And the extra step is basically I convert this string into a particular list. So say suppose I take a variable t and I will convert this into a list. So I convert the string into a list, and then what I do is I take that list and convert that into an array. So I fetch each and every element as elements of your particular array. So it somewhat looks a bit of a looks like a organized array. Now you can also do in a similar manner with sets. You can also do that like that. Store the set in A, so basically I run that and then I get this. So as it is in the set format, you know that the set, if you have already idea what set is, then this would be quite familiar to you. But then again, if you do not have any idea about set basically what it does is that it set do not keep any repetition of a particular value. Like 58 is repeated twice, 18 is repeated twice. So it does not keep repeated values. It shows it just once. So that's why you will get 58 and 18 once out here, and 9. And another thing that is that when you take elements into a particular set, if it's not in a consecutive manner like 1, 2, 3, and 4, it's not in a particular like 11, 12, 13, 14, not in a sequential, not in a consecutive manner, not it's very wrong to say sequential manner, rather than if it's not in a continuous manner, then your the position of the digits will be jumbled up. Like as you can see, 9, 58, 18. There is no sense. It's not even in an ascending order or a descending order. So the position gets completely jumbled up. The next thing is dictionary. That is the last literal that we have out here. So you can also convert a dictionary into an array. So we can do this in a similar manner as I've shown above, and as I've stored my dictionary in R. So run that, convert it into an array. Now, if you want to like, are not really sure that it is converted into an array or not, let's store this into a particular variable like t, and then let's just check if it has the dictionary has purely converted into array and has been stored in T or not. By writing print and type of T to see the class in which it has converted, it has converted into a Numpy array. So this confirms you that the conversion has really taken place. So you can do that with all the other steps. So the next part is this was creating a one-dimensional array using different literal collections. Then moving on to the next part is if you want to create a one-dimensional array using a series of numbers as inputs using various syntaxes. Now, your first syntax that we are going to use, or first functionality that we are going to use, is called np.arrange. It's more, as you can see from the name, it's range of values. So here the functionality is somewhat like this, as if you can mention the initial value of the range, the final value of the range, and the implementation step. Or you could just leave it in that way. So let's move on. Let's see. Say suppose I want a range of values starting from 0 to 10 or 10 to 30. So basically I write np.arrange. Be careful of the syntax because sometimes we write arrange so there will be A-R-R-A-N-G-E, but no, the syntax is A-R-A-N-G-E, just a single line. So be careful of that part. And then as I told you, I want to print say suppose 20 to 30. So I state my initial value to be 20, and as a final value, the final value is always written in such a manner that it gives you in a n plus, it has to be written in an n plus 1 manner. So I get 31, and then the implementation steps. The implementation steps say I skip with 2, and then run it. So even numbers that are present out here, as you can see, it's 30. If I would have written 30 out here, would have given me till 28. So basically what happens is that as a position value is starting from 0 till the nth position. So if you want to see a range of values from the initial value to the final value has to be in n plus 1 format, so that it satisfies that it goes from 0 till your nth position. So simultaneously I write here 31, so it gives me that. So this is how you can create an array, a one-dimensional array using a range function and having a particular sequence of numbers. The next part is we can also use line space. Now in the line space and the range function there's a difference between it. Line space is similar, you have to state the initial value and the final value in a similar manner like I have done here. But instead of, as I have written, the implementation steps, so it's adding to and selecting the elements out here. Instead of that, you have to mention the number of elements you want to place. So, okay, suppose I want this similar output, right? So I write in np dot linspace out here, and then I have to mention the initial value, which is going to be 20, right? So keeping that in mind, and the final value is just going to be the same. But the only difference being here, the implementation steps are 2, but we have to mention the number of elements out here. So how many elements do we have? We have 1, 2, 3, 4, 5, and 6. 6 elements. If we write we want 6 elements within this particular range, it will automatically divide the entire range into 6 elements and will get you the answer. So you see it in this manner. Now what happens is that as you can see that here you have to mention the number of elements, so it has a property of dividing the number. So it automatically or by default, as it's dividing the range and giving you such values, it will be much more accurate, and it will be shown in a float data type instead of an int data type. So you can also mention the d type out here, d type int, and that will give you just the same results that you were fetching. But out here, as you can see, it's ranging between your 31. So basically, change it and it gives you till 30. So as you can see, the initial and the final value is not just the same, because the initial and the final value out here is starting from 0 to this, but as it's dividing a particular range, so you have to keep the range maintained. So here the position value will be taken according to the number of elements that you put in. Okay, so now as you are, well, now you know how to use range or arrange and the line space functionality to give you a sequence of one-dimensional array. So we move on to the next part, where we use random function, which will generate us random values and will give us a one-dimensional or two-dimensional array accordingly. Now here, as we are dealing with one-dimensional array, so let's move on to the part where you can generate uniform distribution of numbers using random function. So for random function, what we do, we write np.random. Now random function here, it helps you in generating the random values. But you have to specify, as we are saying uniform distribution, you have to specify a particular functionality, that is rand. Rand helps in giving you uniform distribution. Uniform distribution means random selections of numbers ranging from 0 to 1, maintaining 0.5 mean all the time, be it how many range of numbers you want. So after I mentioned from where random function and rand function for my normal distribution of numbers, or fetching me random numbers, but with maintaining your normal uniform distribution, sorry, not normal, uniform distribution. So basically after this you have to mention the number of elements you want. Say suppose we want say 10 elements. If you write it in this manner, basically it will fetch you 10 random elements in a one-dimensional array. It is shown in a two-dimensional format, but you have to remember these brackets are the ones that denote the dimension in which it is. So basically it's a one-dimensional array of randomly generated numbers. Now what I mean by randomly generated numbers is, if I run this again, you will see this output to be changed. See? So it's basically fetching you random numbers one at a time. Right? So this is how I'm generating uniform distribution numbers, ranging from 0 to 1, keeping a mean of 0.5 altogether, which is a basic definition of uniform distribution. And I am asking for the number of elements. So basically, if I write just 10, that will give me 10 randomly generated numbers, but maintaining uniform distribution. Similar manner, we can also generate a standard normal distribution, and we're going to do that somewhat like this: np.random, just the same as the previous function, just in this case, as is a standard normal distribution, which is from -1 to +1. It has a different syntax, that is rand. And here too, you can specify 10, the number of elements you want to be generating, and it will give you as well as positive and negative numbers, like a standard normal distribution. And here too, if you run it again, it will generate you different numbers or fetch you different random values. Moving on to the next part is, say suppose we want a random generated integer numbers. Now for integer numbers, it's not maintaining, like in standard normal distribution and uniform distribution, it has a inbuilt criteria within which or a range within which it had to generate or give you the random values. So for random integers, you have to mention the range in which it will fetch you in a random manner the values to you. So here too we have to do just the same, np.random. So up until here it will generate your random numbers. Then next is you have to mention what kind. So if I mention rand n, it will give me a standard normal distribution. Rand is uniform distribution. But here I want random integers too. So I write rand int. Is the syntax for generating random integers. The next thing is that we have to give the range to it, right? So basically I give a range from 0 to say suppose 10, and then the number of elements you want to generate. Like here you just have to write the number of elements, but here you have to specify the number of elements you want to generate. Say I want to generate 10 elements of itself, and it will give me 10 elements in an array, and it will change similarly like it used to do for a random functionality. It's changed each and every time. Now as you can see that I have asked from 0 to 10 elements, right? And it is generating me repetitions of quite numbers. So as it is randomly distribution or randomly generating numbers, so we can expect these kind of repetitions. Now the next part is we can, by defining the size of the array, we can generate a particular one-dimensional array. Now here there are two processes in which you can generate a null matrix or a matrix filled with ones. Okay? So there is a syntax in which you can generate a one-dimensional null matrix, and that is by writing np.zeros, and after that you have to mention within a bracket the number of elements. So stating this, by stating here, you can just by mentioning the number of elements, and as you can see it's not in like if I go ahead and increase it, I can increase it as much as I want. Let's say suppose I want 20, so it will generate me 20 elements in one dimension. And if I do that, it gives me 20 elements in one dimensional array. Now as you can see, by default it gives you in a float manner, and as I have done earlier, you can also do it out here as I've done in the earlier case. As I mentioned, dtype np.int, so I'm just going to copy this. You can use this functionality right here. This will be given in your integer format. Right? So this is how you can create a null matrix using this syntax np.zeros to generate you a one-dimensional null matrix. Now say suppose we want a matrix filled with ones or unit. So for that too there is also a syntax. You can write np, and then you have to write ones, and the same thing. You can just copy the entire thing that is present out here. So it's the same. So basically we are wanting 20 of those elements, and I can also choose the enter, because if you don't, it will give me all the values in float. As you can see, there are 20 ones in one-dimensional array. Now let's move on to how we can create a two-dimensional array or a multi-dimensional array. First, obviously, we will be working with a collection of literals, and those are lists, tuples, sets, and dictionary. Now here, as you can see, it's a nested list, and using this nested list, we can also generate a particular two-dimensional array or even multi-dimensional array shown out here, and it has to be in a nested format. So if I just write np.array like I was doing previously and just mention the list, nested list, it automatically converts it into a matrix format. Fine. Now, if I want to do a multi-dimensional array, I pick a much more complex nested list, which is of a three-dimensional, as you can see from the brackets, bracket notations out here, and as you can see from the elements out here. So, in a similar manner, like we were converting the collection of literals, we are going to just do that np.array and mentioning the literal, and it will convert that into a three-dimensional array. Now this was for your list. You can do the same for the others, like you can use a dictionary, a set, a tuple, but accordingly, a list is mostly used in most of the cases, because the nested list is much more clear and much more easier to understand, rather than it becomes much more complicated for converting a dictionary into multi-dimensional array. But obviously you can convert and do that. You can give it a shot and do that. Next is using a series of numbers as inputs and using various syntaxes. Like as we have used arrange and line space functionality for creating a one-dimensional array, we can also do that and convert those one-dimensional array that we have previously used. That means if I just print this, then it's going to generate me a one-dimensional array, right? So as it is a one-dimensional array, how can we convert this back to a two-dimensional array? And as we have taken elements according like 25 to 50, there is 25 elements present inside of it. So basically, 5 cross 5 matrix is going to be perfect to fit the number of values, and to be converted that into a two-dimensional array. So how to do that? So to do that, what you have to do is first you have to mention the variable in which you are storing the one-dimensional array dot reshape, and then basically you have to write the number of rows and the number of columns. That is, the number of rows is 5 and the number of columns is 5. So as I have 25 to 50, so it has 25 elements, so 5 cross 5 matrix is just going to be fine. So we can store this in S maybe, and then print S. Then you can see this one-dimensional array has converted into a two-dimensional format, right? Now, if I change the dimension, say suppose I say it's a 5 cross 6. Now 5 cross 6 is going to be needing a larger number of elements. So I say suppose it's going to need 30 elements, but you have only 25. And if you run then it will show you an error saying cannot reshape array of size 25 into a shape of 5 cross 6. And if you even decrease it, say suppose in some scenario you decrease that into 20 elements. So 5 cross 4, that will be requiring 20 elements to be converted to a two-dimensional array. Then too it will show you an error. So whatever elements you or what number of elements, depending on the number of elements you have out here using NP arrange, uh, depending on that you need to shape it, or you need to give a particular shape to it, and according to that it can be converted. So it cannot be greater than or less than so that you can convert it easily, but you have to be right on the mark to convert that into a two-dimensional array. Now later on we can also see that how we can convert it into a three-dimensional array. Now for the three-dimensional array, what we are going to use is 5 cross 5 cross 5, that means 25 elements. So 125. We take, so say copy this, it's a bit better, it just makes it easier for us. So I will take 125, so basically I will just say arrange from 0 to 125. Okay, incremented by 1, and then if I run this, it's showcasing an error. So 5 plus 5 plus 5, that will require. So as I have been telling you earlier, so basically we will copy and paste this statement that we have used for creating the two-dimensional array. This right here. And as we are taking 5 plus 5 matrix, so basically we are considering 125 elements. So I'm making easier. We can arrange from 125 and then reshape into 5 plus 5 plus 5. So three-dimension, and then basically if you run it, you will get a three-dimensional array out here. Now moving on to the next part is we are going to have a 3 cross 2 matrix, that is a two-dimensional array using line space. As you have known what we did previously with line space is basically it you have to mention the initial value, final value, and the number of elements. So this by itself will, if I write print of t, that will generate me 6 elements of a one-dimensional array. So in the similar process, if you want to convert this one-dimensional array into a two-dimensional one, we are going to do it in a just similar manner. So basically we are taking some variable and then mention the one-dimensional array dot reshape, and then reshape it to what 3 cross 2 matrix. And then if we just S and run it, it will generate us 3 rows and 2 columns two-dimensional array. using line space. See, suppose we want to, generate a three-dimensional array of 3 cross 2 cross 3. So, in the similar manner that we have done right here, we can just copy this, paste it right here, and instead of like number of elements, if we have considered 18 elements, depending upon the shape, so you have to always maintain that. You have to always keep that in mind. You can't reshape it with an uneven number or something that doesn't match with the shape, because that's why I've taken 18 elements out here and 6 elements out here. So that into 3, that is my 3 dimension, that is 3 cross 2 cross 3, which is my dimension, so 3 dimensional array. So it will generate me a 3 dimensional array right here in a similar manner. The only thing that you have to keep in mind is when you are reshaping it, the shape, the size of the shape, or in which the number of variables you're going to put into a reshape into 3 dimensional or 2 dimensional matrix, you have to keep in mind the number of elements should match that particular shape. It can't be bigger or lesser than particular value. Then we move on to the next part, is how we can use the random functionality to generate a 2 dimensional or a 3 dimensional array. So first we are going to generate a 2 dimensional array having a uniform distribution. So for generating uniform distribution, as I previously told you, we write np.random, then for uniform distribution rand. Then here what you have to do is you have to mention the shape, because random usually when you have to write just 10 out here, it used to give you 10 elements in a 1 dimensional array. But when you want a 2 dimensional array, you need to just mention the shape out here. Say suppose I want a 3 cross 2 matrix, so 3 cross 2 out here, and then if you run it, it will give you a 3 cross 2 matrix with randomly generated values. And here too, it's nothing different. It's going to generate you different values each and every time you run the program. Similarly, you can also generate a uniform distribution having a 3 dimensional array. I'll just copy this one. In a manner, you can write np.random rand and then just write the dimensions or the values, or basically the dimensions you want, and it will generate you a 3 dimensional array. Now, in a similar manner, you can also generate like a 2 dimensional or 3 dimensional array using standard normal distribution values, randomly generated standard normal distribution values in a similar manner. Like np.random in, and then just okay. Random, and then just mention the shape you want. So similarly, like I'm saying 3 plus 3, and it's going to generate a 3 cross 3 matrix of random normal distribution, randomly generated values. And here too, if we want to generate a 3 dimensional array, we write in the similar manner np.random ran in, and then we write the dimensions of the 3 cross 3 dimensional array. And it will give me in a similar manner a 3 dimensional array. So moving on to the next part is integers, right? So see, suppose we want to generate a 2 dimensional, 3 dimensional array for randomly generated integers. So first you have to do write np.random.random, which for both the cases is just the same, and you have to mention the initial and the final value of the range of integers you want. The next thing to generate, usually if you run this, it used to generate you just a particular one value, because I have just mentioned the range out, you have not mentioned the number of elements I want. So the next step that you have to do to convert this into a 2 dimensional array is you have to write comma size, and then within brackets, and you have to write the size or the shape of the 2 dimensional array. So suppose I want 3 cross 2 and run it. It will give you a 3 cross 2 array with randomly generated integers. So if I run it again, it's going to change again. Here too, if I want to convert that into a 3 dimensional array, or I want random integers into a 3 dimensional array, similarly you have to do it out here. You have to mention size equals to, and within brackets you write, say suppose I want 3 plus 3 plus 3. To do that, I will get a 3 dimensional array in a similar manner. So this is how we are going to generate, using random function, we can generate a 2 dimensional or a multi-dimensional array. Moving on to the next part is like we have used a null matrix, we have generated a one-dimensional null matrix. We can also use that to generate a two-dimensional or a multi-dimensional null matrix or a unit matrix. So how can we do that? Like in a similar manner as we have done before, we can write np dot for nulls we can write zeros, and you have to mention the shape out here. Like see, suppose for we have mentioned out there 10. So if we write 10, it will give me just 10 elements or 10 number of elements, all zeros. But here you have to write a particular shape. To give a particular shape to it. Basically, you put another bracket and you write the shape within it. So I want a 3 cross 2 matrix having all null values. So it will generate it in this manner. So if you write it and run it, so it will generate 3 cross 2. But here too, you can also write type np dot int, and it will also then here too it will convert these float formats into integer formats and give you a clean matrix. Now similarly, like here we have generated for a two-dimensional matrix, we can also do that for a three-dimensional one. Only change is you have to change the shape, given a three-dimensional shape to it. So once I do that, I'll get a 3 cross 2 in a three-dimensional manner right here. So in this similar fashion, if we also do it for the uh, unit matrix and to generate a two-dimensional or three-dimensional array, we can do it similarly somewhat like this: np dot ones, and then just in a similar manner, like we have mentioned the shape and the d type, we also do it out here, fine. And then we run this, it will generate me a particular matrix. And using the same syntax, if we run it out here and just change the dimensional for a three-dimensional matrix, we get three-dimensional unit matrix. Now moving on to the next function. Okay, now moving on to the next part is where we can create a multi-dimensional identity matrix. Now, as we are talking about identity matrix, as if you have previously studied in class 11 years, identity matrix is the one where the matrix has to be a square matrix, firstly, and the second thing is that all the diagonal elements in that particular matrix is going to be 1, and all the other elements are null. So let's see how we can generate the multi-dimensional identity matrix. So identity matrix cannot be a one-dimensional matrix. It always is a multi-dimensional, two-dimensional matrix. So to generate that, you have to write np.I, and just in the brackets, you have to mention just one particular dimension. As identity matrix can only work on a square matrix, so hence you have to just type in the, say suppose you want a 3 cross 3 identity matrix, and you just have to mention any one of the dimensions, just one, and by this it will automatically generate you 3 cross 3 multi-dimensional or a two-dimensional matrix as for this case, and identity matrix. And here too you can also write d type equals to np dot int for cleaning up the data or converting the float numbers into integer values. Now, as we have already used and we have shown you that using the np.random, you can generate random numbers, or you can ask a machine to give you random numbers and convert that into an array and give it to you. But you can also say generate them just once and you want to fix it. Say suppose you want to fix the random generated values by what it runs at the initial stage. Fine. Then basically you have to write np.random, and to fix the random functionality we write seed and we give a particular value. Say suppose any value, say I give 1. Fine. Now how does the random function works out here? I'm going to share you a little of the history. It's basically the random function. So if you ask a human being to give you randomly generated values to you, then for a human it's quite easy. For a human, it will not rely on any sequence, or it will not rely on a particular manner it should generate, and it will just give you in a random manner, um, random values to you. But for a computer, generating a random value is quite difficult. For a computer, whatever input you throw it will give you the corresponding output. So a couple of computer engineers designed this particular or found out this particular algorithm which will help the machine or the computer to generate random numbers by itself. Right. So to generate, when we are giving the np.random function and without using the seed function, what it did is each and every time you run the random functionality, it gave you randomly generated values. Right. So this algorithm, like any other algorithm, also requires an input to give you a particular output. The machine, it also requires an input. And to give you an input, it also has a randomly generating input functionality, which gives a randomly generated input, which is also a sequential manner in which it contains. And using that input, it runs the random generated values algorithm, and using that algorithm, it gives you a particular random set of numbers depending on your requirements, 10 to or in a particular shape. But seeing that value, you feel it's randomly generated, but it is not. It is predetermined. So it is semi-random, semi-predetermined. Because visually, it seems like it's a random value, but the computer knows that it is running through an algorithm, so it's predetermined. So using the random functionality, we can generate or we can perform or make the computer perform that functionality. But when we want to fix the randomly generated values, how we are going to fix it? We are writing dot seed, right? And then out here within the brackets, I am giving a particular value, say 1. Now this value, when I'm each and every time I'm running this value as my input. So this is basically my input to the randomly generating algorithm. So each and every time I run this is a particular input that is going inside the algorithm each and every time. And that's why it seems to be fixated. Let's see how it works. Then say suppose I write np.random and say I want 10 elements just for now. So it's giving me this. And so each and every time I'm going to run this, it's going to give me the same results. 4.17. If I run it again, it's going to be 4.17. So what happens? Through the seed functionality, we are giving a particular input to that particular algorithm. And hence it is giving me, according to that algorithm, it's generating me the same set of randomly generated values. Right. So these are known as your pseudo-random numbers. Pseudo means semi-random, semi-predetermined. Okay. And now if I remove this, if I do not give anything or enter anything into the seed functionality, you will see that is going to generate or do the same functionality that random used to do. It will give me different values each and every time I run it. Right? So putting this value is acts as your input and it gets fixated. See, I got 4.17 again. Now, say suppose if we want to convert that into a particular array or a two-dimensional array. Now 2, you have to write something like this. Copy the statement again and just paste it out here, and then I run the same functionality, random dot, and then I can change it into two-dimensional array, same command, and the run functionality, say suppose I want 3 cross 3. So it will give me a fixated 3 cross 3. So this is how, and these are the various methods using which you can generate a one-dimensional as well as a multi-dimensional array. So for today, I have told you and you have got a various idea about how you can create an array using Numpy module. And in the next video, I'm going to upload and show to you how you can access a particular array. So until then, explore and have fun using Numpy.